In 2014, it took $23.63 to equal the value of $1 in 1913. In 2000, it took only $17.39 to equal the value of $1 in 1913. The amount that it takes to equal the value of $1 in 1913 can be estimated by the linear function v, given by v of x is equal to 0.4306x plus 11.0043, where x is the number of years since 1985. Thus, v of 10 gives the amount that it took in 1995 to equal the value of $1 in 1913. So use this function to predict the amount that it will take in 2018 and in 2025 to equal the value of $1 in 1913. So this is just a function that models inflation for us. The first step, let's look at 2018, is to figure out how many years after 1985 2018 is. So 2018 minus 1985 gives us 33 years. So that's our x. So in our function, we're calculating v of 33. And so we have 0.4306 times 33 plus 11.0043. Okay, so this gives us that in the year 2018, it'll be $25.21 to equal the amount of what would be $1 in 1913. Now for 2025, do the same process. 2025 minus 1985 is 40 years after 1985, so that's our x. So v of 40 is 0.4306 times 40 plus 11.0043. And this gives us $28.23. For the second part, we want to find out how long will it be before it takes approximately $32 to equal the value of $1 in 1913. This is where we do not know x, but we do know what the amount is. So we're going to plug 32 in on the left side of the equation. So we get 32 equals 0.4306x plus 11.0043, and we want to solve this algebra equation for x. You begin by getting the x term by itself, so subtract the 11.0043 from both sides of the equation. So 32 minus 11.0043 is 20.9957. And now we want to get x alone, and it's being multiplied by a coefficient, so you divide both sides of the equation by 0.4306. To get 48.759. Okay, now remember, x is the number of years after 1985. So we really want to know the year, when will it take approximately $32 to equal the value of $1. So round this to 49 years after 1985 and then calculate what that year is going to be. So 1985 plus 49 years is in about 2034. The cost of inflation will make what was $1 in 1913 be $32.